And this is the final question, question 8. Oh, I think this is going to be messy. So you need to first of all find the equation of a tangent to this curve, but at the point x equal to a. So we don't actually know what a is. I'm just gonna start usually with the usual. Let tangent be y equals to mx plus c, and I'm just gonna try to find m and c. So let's start with m. The curve is 2 over x squared minus 1. I'm going to write it as 2x to the power of negative 2 minus 1, just to make it a little bit easier to solve. dy dx, well, to make it easier to derive, is now negative 4x to the power of negative 3, which is negative 4x cubed. So when x equal to a, dy dx will be negative 4 over a cubed, and this is also going to be the gradient of the tangent, which is m. So right now we have y equals to negative 4 over a cube x plus c. Okay, in order to find c, what I'm going to have to do is to find the y coordinate of the point where the tangent touches the curve. So if x equals to a, then y would equal to 2 over a square minus 1. So the point is a, 2 over a square minus 1. And if I substitute these x and y coordinates into this equation, I will have 2 over a square minus 1 equals to negative 4 over a cube times a plus c. Doesn't look as bad as I thought. So 2 over a square minus 1 equals to negative 4 over a square plus c. So you move this to this side, you ended up with 6 over a square minus 1 equal to c, I think. Okay, now from that I know that the tangent is y equals to negative 4 over a cube x plus 6 over a square minus 1. Let's see whether you would get that. So we're going to go tangent line. The equation is 2 over x squared. 2 over x squared minus 1. Assume this. Oh no, I'm gonna. Well, x equals to a. Is that right? Yeah. Okay, that looks good. So instead of 1, they just write. Why do they have a plus? Oh no, it's fine. It's fine. I think we got it. We got the answer for part A. I'm just gonna leave this here. This is just another way to write it. Okay. Where's the? I don't know where the cursor is. Cursor, come down. It's here? Yes. Oh. No, this is great. All right, in that case, no attachment. Let's go to part B. This tangent cuts the axis at b0 and 0b. Find the values of a and b. So the x and y coordinates of this tangent, sorry, the x and y intercept of this tangent is b0 and 0b. You need to find the value of a and b. Now, if it is 0b, then it means when x equal to 0, y equals to b. Therefore, b is going to equal to this part, which is 6 over a square minus 1. Okay, this is going to be fun. I'm going to write it as 6 minus a square over a square. The second one, when x equals to b, and now you know b is this, which is also equal to 6 minus a square over a square, y equals to 0. So if you substitute these x and y values into the equation, you have 0 equals to negative 4 over a cube, multiply with 6 minus a square, let's throw in a bracket, times a square plus 6 over a square minus 1. Let's move this to this side. I have a square minus 6 over a square equals to negative 4 times 6 minus a squared, a to the power of 5. This is just keep getting better. Alright, I need more space, so still need to find that cursor eventually. How can I go down? This is not good. Oh, this is how you go down. Alright. It's gonna happen any moment now. Where is anything? Alright, we have more room. Hopefully you don't get this question in a non-calculator exam, because it's pretty messy. Well, alright, let's rewrite. Boo. Try again. Yep, up here. A squared minus 6 over a squared is negative 4. 6 minus a squared on a over a to the power of 5. Alright, I'm gonna move the a to the power of 5 first. What is the good way to do this, and why is everything so messy? Okay, a squared minus 6 times a to the power of 5 over a squared is negative 24 plus 4a squared. So I can cancel the a squared out, I think. So you have a squared minus 6 times a cubed equals to negative 24 plus 4a squared. Expand a to the power of 5 minus 6a cubed and move to this side, minus 4a squared plus 24 equals to 0. Now you need to solve for a. I do not like this. I don't think 1 will work. 2. You know what? I think this is the point when we use the cast. You might get this in the non-cast exam though, but I think a power of 5 is a little bit too much for year 11 to do by hand. Where did my equation go? My equation, okay, minus 6 times a cubed minus 4 times a squared plus 24 equals to 0, and we're solving for a. Yes, it was a good idea using the cast because the answers are nasty. I'm just going to define b in terms of a is 6 minus a squared over a squared. Okay. 6 minus a squared over a squared. Okay, so b of the first one is negative root 6. So you got that. The second one is root 6. Oh, let's go with 2 to the power of 2/3. Wow, isn't that lovely? And the last one is square root of 6. Okay, so that's it for the last question.